Timothy, what's up? Okay, okay, all right. Jamal, good evening, bro. How you doing?
Hello, bro. How are you? I'm good.
Okay, all right, thank you. Let's just give it a bit of a minute. Let's say, let's say 10 minutes past 5, then we can start properly. Let's give everybody enough time to join in.
Okay, okay. Can you hear me? Is my voice clear?
Yeah, your voice is very clear.
Yeah. Okay. Thank you so much.
Hello, good day everyone. Can we all hear me?
Yes, I can hear you.
Okay, before the meeting begins properly, let's just give few more minutes for others to join the call and then we'll start the meeting properly. Hello, if you are just joining, we are going to be starting by 5:10. So we are just waiting for every other persons to join the call. So exercise patience with us all. Hello, good evening, everyone from Nigeria. So, my name is Timothy Ignatius, and on behalf of Benin Solidworks User Group, I want to thank you all for joining us today. We have an exciting session ahead of us titled What If? Mastering Design Study Simulation. If you have ever wanted to automate your trial and error process, to let SolidWorks optimize your geometry for you, you are in the right place. Leading us through this is our featured speaker, Sdiri Jamel Edine. Jamel Edine is a CSWE and a SolidWorks and 3D Experience application engineer with deep industry expertise in simulation. He's going to walk us through parametric optimization, constraint management, and as well how to seamlessly integrate SolidWorks simulation early in our workflow. For those of us that have a lot of questions, we have a live Q&A session at the end. So please be prepared with your questions. Jamal, we are thrilled to have you today.
Thank you so much. Thank you. So, are we going to start, or we wait a little bit more?
Yeah, you can go ahead.
Okay. Okay. Hello, everyone. Let me just share my screen. And start the presentation. Okay. Can you see my screen clearly? Hello, can you hear me?
Yes,
Yes, you
I
can.
can.
Okay. So today, as Timothy said, we are going to present mastering design study simulation using SolidWorks. First of all, I'm going just to present myself a little bit. I'm Sdiri Jamel Edine. I am a SolidWorks application engineer from ABBK PhysicsWorks. Also, as he said, I'm a SolidWorks expert. You can get in touch with me using LinkedIn. So I will start with a brief introduction for what is like part design workflow. So for every part or every machine, everything starts with like an idea or a need. Either I have an idea of an innovating project, or we have a need for like in our industry for a part that will solve a problem occurring in our industry. So moving on from the first step, we need firstly to start like drafting, making the shape of the idea, like sketching the first drafts of our part. Then we will move on to 3D modeling, start creating our part, start making the measurement to fit properly in an assembly, or either if it's a new project, start preparing like the bill of materials, start preparing every need of the 3D model part. Moving on to like after we finish like the assembly or the part, we need to check our measurement to check our requirement. Does it like able to be manufactured with our existing manufacturing tools, or does it fit the requirement of our client or something like that? So after we check the measurement and everything, we move on to the simulation to see if is our part is our part will resist to the environment like constraints that we will have, and does it resist to the boundary the condition that it will be working in. So after that, if we validate our part, then we will deliver it to the manufacturing. But in some cases, like if I run a simulation of my part, I will get like maybe by chance I will get my part is all good from the start. But in some cases I will get like some problems in the overall geometry or even in the shape. So I need to like to do redo like the modeling once again and check my measurement. Then I will do the simulation again. After that, I will like get the result. If they are okay, I will pass. If they are not okay, I will redo the process again and see if like for example, if I have the length of my part that is variable, so I will change the length again and I will run the simulation again and check the part again. Like this is like really time consuming and it's very frustrating to not get like a good result from the start. So like here I put it the engineering challenges like my part must be strong, light, and performing well in the environment where I will put it. So like this is called like the traditional workflow. So I will change one parameter, do the simulation, and repeat. If it's okay, I will pass. If not, I will repeat from the starting point. But in this presentation, I will introduce you another feature called the design study simulation in SolidWorks, which will help you define some variables and add some constraints and to reach a specific goal. For example, I need my part to be light, like it's not heavy, and needed at the same time I needed to resist to the, for example, to the real strength of the material that I'm using. Or for another example, I need just to minimize the weight. My part is resisting, but I need just to minimize the weight. I will. I cannot change the shape of the part. I cannot change any value of the measurement, but can only change the material. Everyone know how is changing the material in SolidWorks. It will be like frustrating to change the material each time to run the simulation. Also, for example, if you have I don't know, for example, if you have a gear part with some holes inside to reduce the weight, for example, your part will resist, but it can be much more lighter and it can resist more. For example, you can change the number of the holes, the diameter of each hole, all of that with using design study. You just first let me pass to the next slide. Here you can say like you can see like the tab of design study. When you click the design study simulation button, this small tab will appear on the bottom of your SolidWorks application. Here you can firstly here you set your variables, then here you set the constraint that you need to make sure that you will not exceed, and after that you will put the goal that you want to reach after this simulation will occur. So uh, here I'm going to start with three types of application. I'm going to do design study on sheet metal parts, on a solid part, and on a beam part. Each one I will define a different variable, and we will see like the results and what I will have. So let me just start by opening SolidWorks. Here you can see my part opened. So as I said, the first part is modeling our part. Here my part is is complete. Then I will pass it to simulation. I need to create like my first simulation. I will do just a simulation. I will run a new study, create static simulation. I will just create simple one. I will just apply my material. I don't know. I will apply alloy steel. For example, I'm taking like just an example. Then I will fix my these bolt holes. I will fix them. Then I will click OK. After that, I will apply, for example, a force on this cylinder here. I will just use force. I will specify these faces. Then I will put it normal to this face with the force, for example, of 5,000 Newton in the minus Z direction. Then I will click OK. After that, I will run my simulation just to check my part. It will run quickly. As you can see here, if we are a little bit closer to to the yield strength of our material, my part could fail, and I could have problem in real life in real life case. So what I'm going to do, for example, I'm going to change some variables of my part. I'm going to change, for example, the most common thing for example for sheet metal parts is to change the thickness of your sheet metal part. So in the in the traditional case, I will go back to my model. I will change the thickness. Then I will go back to the same simulation and I will run it again. If it's okay, I will pass. If not, I will go back. Then I will do it again. But I can use now design study simulation. So I'm going back to, if we have two options, either to click new study and select design study, or either to go to evaluate and we have also here design study. So the first thing you need to do is to define your variables. So when I click here, I've already defined some variables, but I will delete them and define new ones. I will delete both these variables and create new ones. So defining your variable, when I open the parameter tab, all the variable in my part will appear. So I can select any one of them. So as I said, I will vary my thickness. I will type in here thickness. Then I will click on link to link it to the thickness. So I will see what is my thickness. It's over here, and I will click it like this. I will select the thickness. Yes, okay. It's now linked to my thickness. When you get this star over here, it means it's linked to the thickness, and you get directly your thickness value over here. So I will click OK. Now here I have my thickness value. I have three options. Either I have a range with a step. For example, I will say my thickness is varying from 2 millimeter up to 10 millimeter, and I would just want a variation of 2 millimeter, each 2 millimeters. Then, like for this case, it will give me total active scenarios. I will get five simulations. So after I put my variable, I will move on to the constraint. Here in the constraint, we need to add some sensors to my part. We go here to sensor, we click add sensor. I am going to set a constraint that I don't need to exceed the yield strength of my material. So I'm going to simulation data. I will choose simulation data value, and I will monitor the maximum von Mises stress, and I will change this to megapascal. Then I will click OK. Now I go to the constraint. I've added this sensor here. Its name is stress2, and I want to that my value is lesser than my yield strength of the alloy steel, which is 600 around 620 megapascal. Now I need my goal here is to have the best thickness that it will pass the simulation, and also I need to minimize the mass of my part. Like for example, let me say if 5 millimeter is okay, that this means 10 millimeter also is okay. But it's like ironical to put like a 10 millimeter part for a small place or for a small use. So I will just say here my goal. I've already defined a mass sensor, and here I would say minimize the mass, or we can say maximize the mass if I want to maximize my mass, or I have another option is close to a specific value. So here in this case I will put minimize my mass. Then directly we click run this study. It will run like super fast. It will not take so much time to run all the simulation. So as you can see here, it's varying the thickness of my part. You can see the thickness varying. So in this case, the optimal thickness is 8 millimeter with yield strength, or with like a vomesis, maximum vomesis stress of 614.5 megapascal, and with a weight of 150, around 150 gram. So I can say this okay, but we can like minimize the gap. So I know it's 8 is good, and the minimum value is 6 millimeter is bad. So I will change here my value between, for example, I will change between 6 and 8, and I will reduce the range, the step range to 0.5 to get better result. Then I will run it again. As you can see here, I'm moving on closer to 8 millimeter, and even 6.7.5 didn't pass. So the optimal result is to have 8 millimeter of thickness in this part to pass this simulation. So now I will back to explain a little bit more what are the variables that we can have. I will just click add parameter. So here we can have a model dimension from my part. Like these are the dimensions that I put it in my part. Also, I can have a global variable. For example, I've used this in some case when I have like a number of holes to reduce the mass in my plate, and I will like put the variable. For example, I will put a variable. I will call it number, and this variable defines the number of the holes in my part. Then I will select the global variable, and here I will select my variable. For example, I will name it number. Then here I will get the number I've put it already. For example, I put 6 holes. Then I will link it to it. Then you click OK. After that, I will here in the variable. For example, I will set the range from like I don't know 2 to 10 holes with a step of 2, and give me what is the minimum mass I will get with the most efficient part. Other than global variable, we have simulation variables. So if like when you as you can see here, when I click this, I move on to the simulation. For example, in some cases, my part is good, but I want to know what is the maximum force that it can resist. So here I will add a new variable. I will call it force, and here I will link it to the force variable that I put it, like the static force. I will choose it, double click it, I will choose it. I want this value. Why doesn't go? Force. I just want to link it to it. I think that I cannot link it to it. I don't know why. I think that's there is a problem, something with it. Select a component. Click OK. Check it again. Yes, it's already linked to the force value. Now we just have to set a force between, for example, I've set the value of 5,000. I will set it between 5,000 and 10,000. This is too much, yes, because 3 Newton is small. I need to set with a variation of 1,000 Newton. As you can see here, when I'm having now 2 variables, I'm varying the thickness and the force. So this will give me total active scenario of 30 scenario. Like this will take a long time to solve this simulation. I can suppress one parameter. This will reduce the number of the total active scenarios. Like other options I can have other than the simulation data, I will split this, and I will add another variable. We can have also a material. I will link it to the material of my part. I will name this mat. Click OK. And here we select materials. I can select different material. For example, in my company, we have specific material that we are using for manufacturing, such as a part. And I want to know, like, with these dimension, because in some cases, like, the dimension is strict. Like, you cannot change it as you want. If, like, the client said, I need my part is to be in this dimension, you cannot change them, but you can change the material. For example, here, for example, I'm going to change ASI 120. I will apply it. I'm going to choose alloy steel. I'm going to apply it. I'm going to choose galvanized steel. I'm going to apply it. I'm going to close this. Then I'm going to run the simulation. But here, for example, even for this, I'm going to choose. Yes, here the math is correct. Yes, one other thing I need to tell you, like, when you are putting a sensor here, for example, stress 2, you cannot put a sensor, put the same sensor in these two cases. For example, if I need to vary the mass also, I need to add another sensor. I need to add another sensor, like, to monitor the mass. And now I can add this mass sensor. I will just suppress this value here, and I need my mass. I need it to do not exceed, like, for example, I need to not exceed, like, 300 gram. I want to not exceed this value, and I need to minimize my mass. Like, I not want to meet to like to exceed it, and I want to minimize it. Then I will run a simulation. Yes, it says total active scenario is 90, but it's not 90 because I have only 3 materials. Yes, so in this case, I've exceeded my my constraint. But we can, because my value is very great, because we have a thickness of 8 millimeter. So I can change it. For example, we can go back to the variable, change this to 2000 with the same part, and run the simulation again. I think when we are going to get better results here. Optimization phase. What is the first mass of my part? My mass is 1176. So here I'm going to put 1000. And here I'm going to delete both these two because they are interfering with my simulation. And also this. I'm just keeping my value that I want. So then I will run it again. We have 3 simulations. Okay. All of them exceeded the value. So I need to put 1200. Run it again. They all will be, like, good because they're all below 1200. So here I just want, like, to make it clear to you like how to use this feature. So I will be moving on to the other part to do more explaining. So I will use this. Where is it? The other part? Yes, this one. So in this case, this is a part, like, which is going to support a table, but I'm going to we have 4 of it, so I'm going to run just a quick simulation for this part. Quick static simulation. I'm going to apply a material of, like, I will keep alloy steel. Then I'm just going to fix the bottom face, and I'm going to apply a force. Where is the force? Yes, I'm going to apply a force on the top face. I'm just going to say, like, 2350 value force in the negative direction. Yes, as you can see here. Then I will run quick simulation for this part. So I will just put my true scale. So in this case, I'm, like, in the limit, like, I'm all good. Let me just change my value format to better time. My maximum result is 18 megapascal, and my yield strength is 680. Like, I'm all good. So I'm going to keep this value. I'm going back to my model. I'm going to add some sensors so I can use them later in my simulation. I will first, as usual, I will add the mass sensor. Then I will add the simulation data sensor. I'm going to read the von Mises stress in megapascal. Then I will click OK. Now I am going to simulation and choose design study. Here I am adding my parameter. Here I am going to vary the diameter, like the diameter of the base. So I'm just putting a variable. I'm going to call it diameter, and I am going to link it to the base diameter, which is this one. Just click on the value. It will say here 50 millimeter, then you click OK. So, for example, maximum base diameter 80 millimeter and 20 millimeter as a minimum value, depending on my part. So I am going just to put a step of 10 to get much more results. And for the constraint, as usual, I am going to minimize my stress value. But here, like yeah, as you have been seen, as you said, like the my maximum vomited stress is around 18 for this case. So I am thinking I am going to put like in between two values. I am going to put my minimum value, which is 18 that I get it in this case, 18 megapascal, and I am going to go a little bit more to 50 megapascal. I think that we will not exceed this value. I just want to stay in this range. For the goal, always I just want to minimize my mass. Then I will run the simulation. So as you can see here, the diameter of 50 millimeter is like passing the simulation, and we have a rate. Okay, the best result that I've got is in the 20 millimeter diameter. It will give me like a stress value of 22 megapascal and with a value of like 20 gram, as you can see here. Like for the first scenario, 20 millimeter pass, but for the 2 seconds, like 30 millimeter, 40 millimeter does not pass. And after that, we are going back to the 50 millimeter with 18 megapascal. So, like for this case, also I'm going back to the variable view. So, what can I add more? Yes, I just want to show you like the example of the global variable. So I just going to create a simple sketch to show you this case. I'm just going to create a simple sketch here, like quick drafting sketch, and I'm going to have like a small part like this. Then here I'm going to add like a hole with the diameter of 13, for example. Then I'm going to cut it. So this is my part. But now what I'm going to have, I need to to have more of these hole to minimize the weight of my part. So I can just do like a circular pattern, but I'm going to add a variable. I'm going to name it number like this, and I'm going to put 8 as an initial number. Now I am going to do a circular pattern of this around this circle of this feature. like this. But here in the number of instant, I am going to set it equal to this variable number, like this. I have 8 holes, so just a quick static simulation of this part. So let's say this is an aluminum part. There is a simulation with the, let's say I'm going to fix this point. Then I'm going to apply like a force on this face with 1,000 Newton, like this. I know this is doesn't make sense, but I'm just making an example. So this is my simulation. Now I'm going to create a new design study. I'm going to create a design study simulation. Here in the variable, now I am going to add a variable. I'm going to name it number of hole, and I am going to link it to a global variable. Here in this tab, I'm getting to get the global variable that I've had in my simulation, in my part. I'm going to choose number, then I will click OK. Now here, as always, we have a range. So I have also like a range. I can set a range and it will go like randomly. And other that I have a like a discrete value. I need like a specific value. I need to run the simulation for that value. I'm just going to put a range with a step. I'm going to put like yes, between 4 and 18 with a step of 2. Also, we need our sensor. I'm going to minimize my mass. I just want my mass is less than like what is like. Just want to know the actual mass of my part, which is 300. I need my mass is less than 500 gram, and in the goal I need to monitor like I'm going to do it sideways, like the other reverse it. I'm going to monitor the. I'm going to minimize like with the minimal like one means stress with the minimal stress. Like, I'm going to write like run my simulation. Here I'm having 10 scenarios like what the only like the only bad thing in this is like you need to control it better. For example, if I vary like the diameter of the hole here like with a little bit of luck I've got like to this case finally, but in some cases when I exceed this value of 18 the like these holes will like merge in each other and they will create a defective part, and this is like doesn't make sense. Like you need to like to make sense of your variable. For example, like I've said 18, but if I put like I don't know, I will put like 13, 31, like 13. Then I will put like a step of 5 to have less results. Then I will run it again. Now you will see that like these holes they will merge in each other and they will create like a problem in the overall shape of the part. Yes, as you can see here, like this is like unacceptable in like manufacturing. Like this part could fail, like the simulation. Yes, like for now the option 5 like is good with 24 hole is better. But imagine if I reverse these two sensors. If I need to minimize like the stress, I will get like a high stress value with such as a part that it will maybe it could like even break on these points here. It could break, yes, and it will cause me problems in the future. So I'm going to move on for the other example, which is for of the beam type. Here it's already defined. I've defined a beam simulation of this part with 10,000 Newton force on this joint, and I fixed the back joint. In the design study, I'm going to vary like the material, because for beam part you don't have like much more variable. If like I'm going to add a new variable here. Now I just want to add a new variable. If I'm going to put those model dimension, I only get like the length of the beam, and also like the thickness of this part. They don't give you like the all like the curves and the like the measurement of the beam profile. They only give you some, like for example here they gave me the thickness, and here they gave me the overall length of my beam. uh, but like in most cases, like the length is mandatory, so like you need it to be in this length. But the only thing that you can vary is like the shape of it, and also is the material. Here we cannot like change the shape. I can change this thickness, but I can vary like the material. So I'm going to vary my material. We going to choose like different type of material, ASI 120, and I'm going to choose like ASI 304. I'm going to choose the alloy steel, and I'm going to choose like galvanized and also plain carbon steel. These five materials, and as usual, I have two sensors. I'm going to minimize my mass, and I'm going to not exceed like the maximum yield strength that I have here. Also, I'm going to monitor something else. For these kind of parts, like the displacement is like crucial. So I'm going to monitor the simulation data. I'm going to monitor the displacement of my part, and here I am going to monitor the x displacement, like for the deflection of my part. I'm going to monitor it in millimeter, and I'm going to monitor the maximum displacement. I click OK. Here I'm changing my sensor to displacement. I will delete this one. I want like I can see like for this case here, just need to run it, quick simulation. Like the maximum displacement is 60 millimeter. Okay, I need to be less. I just want to be like less than. For this case, 16 is very high. I just want to be like less than 5 millimeter. Yeah, I just want to be less than 5 millimeter, and also I want to minimize my mass. Like I don't want it to be like super heavy that will cause me much more problem, and it will be like if it's like a better material, it will be much more expensive. And this will be like it's not logic to build like a building using these type of beam, with the overall cost will be much more higher than the revenue of the building, for example. I'm going to run the simulation. think it will fail for all the cases because the displacement is very high due to the high stress I'm applying to my material to my beam. For this case, can add another variable. I'm going to add like it's all like your logic. How do you think about your problem? I'm going to add the variable that define my force. And I'm going to link it to my force variable here, and I want it like in a range of here between I've put it in 10,000. I will keep the maximum one 10,000, and all I want to have the minimum one is 5,000. I'm going to select the materials, ASI, this one, this one, and what is the galvanized one? Yes, this one. Okay, I'm going to run it. Yes, what does it do here? Yes, it's only run it for the first one. It just gave like an increment for the first one. Yeah, as we can see here with the ASI 1020, I've got displacement of 8 millimeter. The minimum value is 8 millimeter with a force of 5,000 Newton. Like, I can say like this is a little bit bad for my part. I'm going to change this range in between. No, yes, say okay because it will give a lot of value. Yes, it's iron to keep it 3 Newton. I am going to add 2,000 Newton to minimize the values. Yes, like for this case, for each material, it will run like these all of these steps, like 5 steps, I think, for each one. So what I'm going to do to make it much more better, I'm going to have it to 10 millimeters. Then I'm going to run it again. There are 16 scenarios with the material variable. Yes, make it faster. So I've got the same result for the ASI 1020 with the force of 500 Newton. I'm going to get like 8 millimeter of displacement. Let me put it up to see better results. Yes, I'm going to get almost the same displacement for all the material because they all have the same density. But if we change the type of the material, we are going to aluminum or something else, it will break definitely for aluminum. But if I'm going to other like alloys or something else, it will give me much more better results. But as I say, you need to keep check for the cost of your manufacturing process, because this is like another thing that you need to take care of. Uh, I think that this is all for this presentation. I am going to like to hear your question because this will help me much more explain any problems if you have for this like type of simulation.
Thank you very much, Mr. Jamal. I think
Yes, thank you so much.
A lot of us got value from this call today, and we are really privileged to have you on this call.
Thank
For
you.
for everybody on this call, if you have questions, you can drop them on the Q&A session, or yeah, just drop them on the Q&A session section, and then would ask the question out.
Okay, Jamel, can you hear me, please?
Hello, I can't hear you well.
How are you doing? Thank you very much for this presentation.
Thank you so much. It's a pleasure for me.
I wanted to ask a question. For
Yeah,
this, for the variables,
yeah.
now we have the variables, we have the constraints. Can you like list what and what can actually be on each of them? Like what can we put in places of like the variables? You have for now you have forces and material. What else can we put there? Then for the constraints, what else can we still put there? There's displacement there now. What other things can we put there? Then also the goals. There is mass, right? So what other
Yes.
goals can we actually put? So I just want to know the full capability of this
Ah,
design.
okay. Yes, yes. That's a great question. Okay. So I'm just going to create a new one, a new blank one to explain much more better. Okay. So I'm going to start one by one. For the variables, so I'm going to add a new variable. What do we have here? When I select the category, as you can see, we have four categories. The first one is model dimension, which is each dimension that you have in your part. For example, here, like this is a small, this is a simple part. I only have like the length of it. But in other parts that, as we've seen here, like I could have like, where is it? Like for this bracket here, when I run the design study and go to the variables, I add a new variable. Like for the model dimension, I have a lot of like specs of my part. Also, I can like monitor like the diameter of like the bolt here that I'm going to use. Other than like model dimension, I can have like global variables and like for you all like you've used global variables in like CSWA or CSWP, you know like the capability of it. Like you can put any variable you want, and this will be like much more helpful. Like in those cases, we have when you have like a lot of like configuration of your part, and you need to simulate them all like in the same time. Like instead of opening each part on its own or opening each configuration and creating multiple simulation for each configuration, you can just put on the variables that you have here and run the simulation for all the configuration that you have. Other than that, we have sim variables. Like this is a simple one. Like I have only a force that I can vary here, and in other cases I can have like some like don't know like all other types of forces or loads that I can apply. Like for example, like on where is it? Like for this one, like, this is a static study, but I can have like a torque or pressure or the gravity or all the type of forces that I can have for my simulation. Uh, other than that, like what I have else, we have like material. As you can see, like material is simple. Like you have bunch of types of material, and you are going to test your simulation for all of these materials. Like this is the simplest case. So this is for the variables. Now for the constraint. For the constraint, it depends on the sensors that you put. Like here, I'm going to create a new sensor. So what do I have here? Like have a mass, I have simulation data, I can monitor also the dimension of my part, and I can also measurement. I don't. This is like I will measure a point. Then if it exceeds like a certain distance or a certain diameter, I need to stop my simulation. Like for example, in this case, where is it? Like, this case. In this case, if I vary like what is it? Oh, you say it closes. In this case, where is it? Yeah, in this one. So if I vary like the diameter of these holes, they will get like merged in each others. So I can add a sensor that will monitor the dimension of each one. Okay, I can add a dimension sensor that it will monitor this diameter here. And in the design study, I can add like I will put it between, to make it much more easier, between 10 and 50. I will put like 20 and 50 to get bad results. 20 and 50 with an incrementation of 10. Yes. And here, as I said, like keep this on, and I'm going to add my dimension sensor, and I need to do not exceed this 13. Like I need it to be no, yes, this one, this is like this is a gold. Sorry, I need to minimize like this dimension. I need to be less than 13. So if I run the simulation, they will get collided in each other, and I will lose like this diameter, and this will cause like the simulation to fail. Like for these cases, it will not reject. Yes, yes. You see, like it doesn't count it because like where is like my diameter like no, like I think it much more better to put the measurement. Yes, because dimension will not be lost, but measurement will be lost for this case. For this case, sorry, if we put the measurement of the diameter of my part, if I go back to result, like in this case, and I added a sensor that it will measure this variable, this one here. I want to measure this one here. It's 40. You don't have to save the measurement. Would you like to save it? Yes, save it. It's diameter of 13. Click OK. And here I will change this. I will delete this, and I delete this. Change this to my measurement, and I need it to be close to 13. And I will run it again. You will notice in this case it's been 0, and this is not like the value I need. So the optimal case is 24 here. So what do we have else? As I said, it's all related to the sensor that I can put. I can also put the costing data. Yes, this is like the most like variable sensor to have. Like as you know, like Solidworks can predict the cost of your part, the total cost of your part, and I need my cost like here. I will delete this, and I will delete this. Yes, I will add here like the total cost of my part. I need to minimize it, like the minimum cost. And here I will just put like a stress value. It will need to be less than 120, for example. And I will run my simulation. As you can see, some simulation will fail. And for this case, like this is the best case scenario I have. So that's it. As you can see, like it's all up to you what you have. It's all up to the capability of the sensor that you can put, and all the capability of the variable that you can put. As I can like, let's like summarize. We have like global variables, model dimension, and simulation data for the variables and also the material for the data. And for the sensor, it's up to like for the constraint and the goal, it's up like for the costing data for the some measurement if you need it. Like for in the like in this case, I don't want to get in this scenario, and also for the weight, for the stress value, for the what do I have else? Like for the some dimensions, if I don't want to exceed them, like that's it. Like you can like this these all these examples that I have shown you like now they are simple examples. But in some other cases, you can have multiple variables that you will do and multiple constraints that you need to check to reach like more than a goal. Like you need your part to be with less weight and less cost and much more effective, like with better like resistance. You can put these three goals for the constraint. You need to not exceed a certain mass and to not exceed like a certain length. For example, you put all your variables. You for this example, we only get like four scenarios, which is like for in some cases you can have 100 scenario. You just click run and you have 100 scenario, and it will like be much more time effective, like not time consuming. It will be much more effective than running each simulation on your own and changing each variable on your own, and this will be much more time consuming and much more frustrating. And that's it, I think.
Thank you very much, Mr. Jamal. So a
Thank you.
couple of questions are on the Q&A.
Yeah.
I think two questions are similar, so I'll be asking them together. One of them asks, um, Derek
On,
asks, can it work on multi-bodies?
on antibodies. Yes, it can work on multi-bodies. You can do it on like in an assembly and have multiple parts, or even like in part you can create parts with multiple bodies. And like if the bodies are affecting each other and you need to minimize all the overall mass of your system, it can work with multiple bodies. Like this is like for a single part, but I can add
Okay,
yeah.
okay, sir. So
Like
the
this is
second question, he said, I don't know if we have the time to address the question, but then let me ask. He said, can you show a demonstration on an assembly scenario? Because most parts are interconnected. So it's analyzing part by part, not a tedious process when dealing with assembly for design study.
uh,
That's David Omolewa.
you want like for an assembly one.
So I
Uh,
think he's asking that is designing or simulating part by part not tedious? That can't we do an assembly? That can't we do a demonstration of an assembly, simulation of an assembly?
yes, but I don't think that I've prepared something for this
Yeah,
case.
and I don't think we even have the time to do that.
Yeah,
So
it will
thank you
take
very
us
much.
some time. Maybe in
Yes, sir.
other case, maybe he can contact me or something else.
Yeah,
I can show him
I think
some.
subsequent webinars we can
Yeah,
do
yeah,
that. Yeah.
yeah. Maybe
Thank you,
if
sir.
he could contact me, I would help him in some cases because
Okay,
it will.
fine.
Yeah.
Yeah, fine. So I think there's not much questions on there's not a, there's no question on the Q&A. So I have a couple of questions to ask for for someone that wants to master simulation.
Yeah.
There are questions on the chat.
Okay,
Malik.
okay, okay, I'm
I
just seeing them now. I'll ask them.
Okay.
okay.
So before you answer those questions, let me just ask my question.
Yeah.
So I want to ask, as a professional that you are, for someone that wants to master simulation, what would you
Yes.
advise? Should he should you focus on just simulating? What would be your template on mastering simulation?
For mastering simulation, firstly you need to have like a base ground on theoretical part. Like this is very important. Yeah, you need to get like I don't know, some courses or something like about finite element simulation and like finite element theoretical, like the theoretical part of finite element, the calculation, and to understand it like with a better understanding. The second part is like to have like a good understanding about the tool. Like you can have like you can be like I don't know, like a genius, like you master finite element calculation or like on the theoretical part, but you need to master the tool. You need to know all the tools that you can use. For example, in SolidWorks, you need to know like all the details in simulation in SolidWorks and connect them to your theoretical background. After that, I can guarantee that you will gonna be like you will not find any problem in understanding all the other and like you can simulate anything and you can solve any problem. Like in a summarize, like the first thing is you need to get like a great understanding for the theoretical part. After that, mastering the tool is much more easier than you think.
Okay, all right. Thank you very much. Thank you. Okay, we have a question. Let me just ask a question
Yeah.
from Mali. You can see the Mali said, "What if there is a body with axial forces?"
So what's the problem with that? You can like uh, for example, like a beam or truss body, you can model it, and as you can see, like you can get access to all the simulation data that you've provided and the simulation data that you get. You can monitor the forces, like the inputs, and you can monitor the outputs also. Like you can monitor both ways.
Okay, yeah, because you already explained that any of the forces we can use any of the forces we use, we can call them into the variable part and they will work.
Yes.
So Yusuf said, "Can SolidWorks make simulations of assembly with different types, 1D, 2D, and 3D?"
3D. Yes. Yes. That's a good question. Yes. In SolidWorks, like as you can see here, like let me put a better case like this one. This one is 3D. This one is 3D mesh. The first one with the sheet metal part is 2D. It's modeled as 2D mesh. This is why I put it this all these three examples. And this one, the beam part is modeled as 1D mesh. As you can see here, it's modeled as 1D mesh. Like even for the mesh, it's modeled as like a beam part. It's not modeled as a 3D part or you cannot model it as a sheet part, but as a 3D part. Yes, you can have them all three, and also you can have 2D simplification also. For example, if I'm going to like for this case, I don't think I can do it, but for this case, for this one maybe in simulation, if I create a new simulation, I can have use 2D simplification. If you like to have a symmetrical part with the symmetry plane, you can put your that symmetry plane as your 2D where is it, as your section plane, and you after that you put the thickness of your part here. And also you can have like an axisymmetrical part for spherical part for like cylindrical parts. Okay.
Okay. All right. Thank you. Okay. So Derek asked, "Is meshing important?"
Yes, meshing is important. It's not related to design study, but it's more related to the simulation itself. Like here, like when if like I want to get like the stress in these points here, I need to refine my mesh much more higher to better have much better results in these points here.
Okay, okay, all right, okay. Nino Nase asked, can you compare ANSYS and solid workflow simulation?
Sorry, I never used answers, so I cannot like compare it to pseudo simulation.
Design study work for flow problems.
For flow problems, uh, I didn't use it actually. I didn't use it for flow problems, but I think I don't think that you can manage maybe flow problems for design study. Actually, this is a good question. This is tricky. This is a tricky question. I didn't use it like for flow simulation or simulation for flow simulation. I will look for it and I will answer it later maybe.
Okay, sir. Thank you very much. I
Yes,
think
thank you.
we've been able to have a very wonderful session. Thank you for your time, and thank you for all the attendees for taking time to wait till the end of this session.
Thank you. Thank you so much for all.
Mr. Joseph Celestine, do you have any other thing to say? Hello, I think Mr. Joseph Celestine is having some network issue. So for those of us asking if the recording will be made available, yes, the recording will be made available. It's on our YouTube channel, and you can go there and check it. The link will be dropped on the chat. It has already been dropped on the chat. Then likewise, Mr. Jamal,
Sorry, can you hear me?
some
Can
of
you hear
us
me?
are asking, can we get the presentation slide? I don't know if it's possible.
Yes, yes, I will send it to you. Yes, for sure. I will send it to you, and I will send you the parts.
Or
Maybe you can use them. It's not that much, but I will send it to you. And as I said, like if anyone have any problem or any like something that he want to solve, I'm open to any question later. Yeah,
Okay,
okay,
thank
sir.
you very
Thank
much,
you very
Jamal.
much.
thank you.
Okay. Also, I was thinking about sending an attendance form for, but I don't think that's necessary. Thank you for everyone that stayed to the end. I really appreciate. And for me, I would say this is one of the sessions that I actually understood because it was easy for me to understand and it was easy for me to relate, right? So hopefully Jamel will have you on another session too, so you can actually talk more on this. And Yusuf, sorry about your him not being able to answer your question, but I guess when you get the flyers or the PDF, it becomes the slides, it becomes more understandable. Then you can practice on your own. So thank you guys. The recording will be shared on YouTube, but it's going to take a while. So I will just try and see if it's possible this evening. If it's not, then possibly probably tomorrow evening. But all the same, Jamel, thank you all very much, and I really appreciate you for coming, even if it was impromptu. So thank you guys for coming, and good night, everyone. Please don't forget, if you want to see the video on YouTube when we upload it, just follow us on YouTube, okay?
Okay. Thank you so much, Joseph. Thank you so much. Thank you so much, everyone.
Thank you so much, Jamal.
Yeah, thank you so much.